Welcome to today's lesson. In this lesson, I will be introducing you to the next motion equation, which will help us calculate the displacement, velocity, and acceleration. If you haven't watched my previous videos about motion, I will put the link below. So the formula we have today is v squared equal u squared plus 2as. We will also go through some examples in this lesson. Similar to my previous video, the equation have different symbols depending on the references you are using. The symbol you may encounter is where final velocity is Vf and initial velocity is Vi. The equation can be rearranged in many ways depending on the variable you want to calculate. This means you don't need to remember the equation for each variable as long as you remember one of the equation. Also to mention, in this equation, we have the variable acceleration. And for gravity, the acceleration is a constant 9.8 meter per second square. Let's look how the equation was derived. If you have watched my previous video, the equation for acceleration is changing velocity over the changing time. My previous week video, we discussed about equation below, displacement equal final velocity plus initial velocity times time divided by 2. When we combine the two equations together, we can generate this equation. I will go through the process of how you can do this. This may help you understand the equation a lot better. To combine the two equations together, first we need to find the commonality between the two, which we have the final velocity, initial velocity, and time. Because the new equation doesn't have the variable time, I will eliminate time by rearranging both equations to calculate time. By combining the equations and eliminate time, we will be able to shuffle the variables around. What I did was I moved acceleration to the left side of the equation and the bracket final velocity plus initial velocity to the right side of the equation. When you break down the equation, you'll be able to get 2as equal v squared plus vu minus uv minus u squared. You can eliminate uv with Vu because they are the same. Then you are left with 2as equal v squared minus u squared. When you rearrange this one more time, you will be able to get the standard format for the equation. Now let's go through some examples. First example, if I kick the ball up into the air at a velocity of 8 meters per second, what will be the maximum height the ball will reach? In this example, we will assume there will be no wind resistance. Example 1 is asking to calculate the displacement. Here's the equation for displacement. The information we know is A equal 9.8 meters per second, which is the gravity. Initial velocity is 8 meters per second. Final velocity is 0 because at the maximum height the ball will stop and fall back down because of gravity. When you punch in all the variables in the equation, you will be able to calculate the displacement, which is 3.27 meter. You might be wondering why it is negative. It is because the ball is traveling the opposite direction. Second example, if I throw a ball from the top of the roof toward the ground at the velocity of 10 meters per second, what will be the velocity when it hit the ground? The height from where I'm throwing the ball is 4.8 meter. The first thing to do is to list all the variables that we have. The example is asking us to calculate the final velocity when the ball hit the ground. By inserting these variables into the equation, you will be able to calculate the final velocity, which is 13.93 meter per second. that's it guys. Thank you for watching. I'll see you again next week.